Good morning, this is your Stats Sensei, Mr. Spensei, and this is a test review for chi-square, goodness of fit, and independence. So this is the same scenario as we used in the warm-up, college stats. To investigate whether taking high school statistics impacts college GPAs, a very large school district randomly selects 450 former students out of the more than 20,000 students who are now in college and records whether they took high school statistics or not. So that 450 students that they randomly selecting, that's our sample size out. And so I'm going to go ahead and mark that up as an N for our sample size. And we have a population of 20,000. They also classified each student's college performance based on their GPA in 3 categories. All right, at alpha equal 0.05, determine whether there is statistical evidence that taking high school statistics is associated with college performance. So what I need to do is I need to sit there and go, all right, we need to enter this data into the calculator. To do that, we're going to go blue matrix. And I know we did this in the warm-up, but I want to do it again. And we press edit. Now pay attention. We don't want to include the total. So I have 2 rows and 1, 2, 3 columns when I don't include the columns. And when I don't include the total. So 2 enter, 3 enter. And then we enter 70, 75, 75, 40, 75, 110, and 80 into the calculator. And then we're going to blue quit. All right, now that we have that information, we can actually go ahead and run our tests and get a whole lot of work done. So let's do that. So stat, test, chi-squared test, calculate. When we do that, we ended up getting our chi-squared value and our p-value. Well, we already know our formula is observed minus expected squared over expected. But now we have our p-value of 0.0474. That's the area shaded here. And we have a chi-squared of 6.0978 right there. Please remember, we always go to positive infinity and we start at 0. All right, well, that's nice to know, except I don't have my expected values, but I can get those real quickly like we did in the warm-up. And to do that, you know what? I'm not showing anything. There we go. So let me back up real quickly. So we had observed minus expected squared over expected, and then our p-value of 0.0474, which is right here, and then our chi-squared of 6.0978. And I said that we started at 0 and we always go to positive infinity because we're skewed to the right with the chi-squared distribution. All right, so I can press blue matrix, arrow over to edit, and drop down to letter B. Let me do that again. Blue matrix, edit, drop down to B, press enter. All right, and now we have all of our expected values, 59.61. And we're all we concern ourselves are with the first one and the last one. So we're going to concern ourselves with the first one here and the last one is there. Because those are the ones we're going to use to show for our plug. So our plug is going to be 70, which is our observed value, minus our expected value over our expected value. So 70 minus the 59.611. And then over here, we have our observed of 80, our expected of 70.67 over our expected. And when we ran the test, we went stat test, chi-squared test, and we ended up getting 6.0978. And we also had our p-value of 0.0479. Also need to talk about the degrees of freedom. Well, degrees of freedom for a test of independence is rows minus 1. Well, we have 2 rows. So rows minus 1 and columns, 1, 2, 3 columns minus 1. So 2 minus 1 is 1. 3 minus 1 is 2. 1 times 2 is 2. So our degrees of freedom is 2. Okay, well, we're running a chi-square test of independence. So we need to now write our hypothesis. So taking stats in high school and college GPA are independent and are not associated. Now, if you wanted to swap the order and say college GPA and taking stats are independent, that's fine too. Doesn't matter the order of the variables. Of variable one and variable two are independent and are not associated. The alternative should look exactly like it, except we're going to change a couple words. Taking stats in high school and college GPA are not independent and are associated. All right. So this one had a not associated. This one says are associated. This one says are independent, and this one says not independent. So please make sure that you have exact opposites. All right, our conditions. We had a random sample of 450, single random sample, and that was given to us. Now we need to make sure our sample wasn't too big. To do that, we multiply by 10, and we end up getting 4,500, which is less than the 20,000 population that was given earlier, because that was our population size right there. So in this case, n is less than 10% of the sample. The next thing, all expected values must be greater than 5. And when we go up here and check, it appears to me that our smallest expected value is 49. So definitely all expected values are greater than 5. So our sample is large enough. Okay, this next part, I can actually pull it straight off the table. Our chi-squared value of 6.0978, and this will always be a greater than symbol when we're working with a chi-squared. For with chi-squared, this is always a greater than, equals 0.0474. Now, just to remind you, I went stat test, chi-squared test, get the same information. So our p-value of 0.074 is less than 0.05. 474 is less than 0.05, so we reject the null. And it's from this sentence or this area that I'm going to write my conclusion or begin my conclusion. Because my phrasing is our p-value of 0.0474 is less than our alpha 0.05. We reject the null. And that's exactly what I wrote. Our p-value is 0.0474, which is less than our alpha 0.05. That came straight from there. We reject the null. There is sufficient evidence to suggest that taking stats in high school and college GPA are not independent and are associated. All right, guess what? This right here is our alternative hypothesis. Says the exact same thing up there. So beginning right here, I'm just restating our alternative hypothesis, just putting it in words. All right. I hope this helped a lot. Look forward to seeing you on the next one and study for your tests. Thank you.